Section 250.86 of the National Electrical Code does not specifically address the bonding of cable trench covers. However, it does state that all metal structural parts of enclosures, including covers, shall be effectively bonded to the grounding system. Since cable trench covers are typically metal, they should be bonded to the grounding system to ensure electrical safety. This can be achieved through the use of bonding jumpers or by connecting the covers to the grounding system via the cable trench walls. While Section 230.32 does not specifically prohibit the use of cable trenches for service lateral conductors, it does require that service lateral conductors be installed in a manner recognized by the National Electrical Code. Wireways are a recognized wiring method for service lateral conductors, but it is questionable whether cable trenches meet the definition of wireways. Cable trenches are typically not enclosed in the same way as wireways, and they may not provide the same level of protection against physical damage or environmental hazards. Given the uncertainty regarding the bonding and wiring method requirements for cable trenches, it is recommended that you discuss these concerns with the following parties. Firstly, the local power company to determine if they have specific requirements for bonding and wiring methods in cable trenches. Secondly, the authority having jurisdiction to seek their interpretation of the National Electrical Code requirements and determine if they have any concerns about the use of cable trenches for service lateral conductors. And thirdly, engage with the utility to determine if they are willing to take full responsibility for the cable trench, including maintenance, bonding, and wiring methods. It is important to approach this issue cautiously and to consider the potential safety implications. If necessary, you may need to recommend alternative wiring methods that comply with the National Electrical Code and ensure the safety of the electrical installation. To elaborate further on the bonding requirements, effective bonding creates a low impedance path for fault current to return to the source, which facilitates the operation of overcurrent protective devices such as circuit breakers or fuses. Without proper bonding, a fault condition could energize metal parts, posing a shock hazard. The size of the bonding jumpers would be determined by National Electrical Code Table 250.102 based on the size of the service entrance conductors. The bonding jumpers must be large enough to safely carry the available fault current. Acceptable methods for connecting bonding jumpers include exothermic welding, listed pressure connectors, and other methods recognized by the National Electrical Code. When considering whether a cable trench meets the definition of a wireway, factors to consider include the following. Firstly, physical protection. Wireways are typically enclosed metal troughs with hinged or removable covers designed to protect conductors from physical damage. Cable trenches may not offer the same level of protection, particularly if the covers are not securely fastened or if the trench is exposed to environmental elements. Secondly, accessibility. Wireways are designed to be accessible for installing and maintaining conductors. Cable trenches may be more difficult to access, especially if they are buried or located in confined spaces. Thirdly, listing and labeling. Wireways are typically listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, indicating that they meet specific safety standards. Cable trenches are typically not listed or labeled as wireways. If the cable trench does not meet the requirements for a wireway, alternative wiring methods that could be considered include: firstly, rigid metal conduit. Rigid metal conduit provides excellent physical protection and is suitable for direct burial or installation in concrete. Secondly, intermediate metal conduit, which is similar to rigid metal conduit but with a thinner wall, making it lighter and easier to work with. Thirdly, electrical metallic tubing. Electrical metallic tubing is a lightweight conduit suitable for use in dry locations. Fourthly, cable tray. Cable tray systems can be used to support large numbers of cables and are suitable for both indoor and outdoor applications. When discussing the issue with the local power company, be prepared to provide documentation and evidence to support your concerns. This may include photographs of the cable trench, diagrams of the electrical system, and references to the National Electrical Code. Document all communications with the power company and the authority having jurisdiction, including dates, names, and summaries of the discussions. This documentation may be helpful if there are any disagreements or disputes in the future. It is always best to err on the side of caution when it comes to electrical safety. If there is any doubt about the safety of an installation, it is important to take steps to mitigate the risk. This may involve consulting with a qualified electrical engineer, conducting a thorough inspection of the installation, or recommending alternative wiring methods. Remember that the primary goal is to ensure the safety of people and property. Regarding the utility taking full responsibility, this would involve a formal agreement that clearly defines the utility's responsibilities for the cable trench. The agreement should address issues such as maintenance bonding, wiring methods, and liability. The utility would need to have the resources and expertise to properly maintain the cable trench and ensure that it meets all applicable safety standards. If the utility is unwilling to take full responsibility for the cable trench, you may need to consider alternative solutions, such as relocating the service lateral conductors or installing a different type of wiring system. Consider that Section 90.2.5 also plays a role. This section clarifies the scope of the National Electrical Code, specifically addressing installations under the exclusive control of an electric utility. It states that the code does not cover installations used by the utility for the generation, control, transformation, transmission, and distribution of electric energy. This exception is crucial when determining whether the National Electrical Code applies to the cable trench in question. The key phrase here is exclusive control. If the cable trench is under the exclusive control of the utility, meaning they have sole responsibility for its maintenance, operation, and safety, then the National Electrical Code may not apply. However, if the customer owns the structure and the utility merely uses it to run their service lateral conductors, the installation is likely subject to the National Electrical Code requirements. This is reinforced by the fact that the local power company requires the cable trench, but it is customer-owned. This arrangement does not automatically place the trench under the utility's exclusive control. Therefore, unless the utility formally assumes full responsibility for the cable trench, it is generally subject to the National Electrical Code. The utility taking responsibility would require a formal agreement transferring control and liability to them. In the absence of such an agreement, the customer, and by extension, the electrical inspector, must ensure that the installation complies with the National Electrical Code. This includes proper bonding, using recognized wiring methods, and adhering to all other applicable requirements. Consider NEC 230.6, which covers underground service cable requirements, including protection from damage. Although not specifically mentioning cable trenches, the general principle of protecting service lateral conductors applies. The installation should prevent physical damage from digging, backfilling, and other potential hazards. The depth of the trench, the type of backfill, and the presence of any protective measures like concrete encasement all contribute to the overall safety and compliance of the installation. If the existing cable trench does not provide adequate protection, it may be necessary to upgrade it or use a different wiring method altogether. Also, NEC 314.30 covers boxes, conduit bodies, and handhole enclosures. While a cable trench is not exactly a box or conduit body, the principles of supporting and securing conductors within it are relevant. Conductors should be properly racked and supported to prevent strain on connections and to ensure that they do not come into contact with sharp edges or other potential hazards. The spacing between supports should be in accordance with the National Electrical Code requirements for the specific type of conductor being used. Furthermore, consider National Electrical Code Section 392, which covers cable trays and should also be reviewed. Although a cable trench is not a listed cable tray system, the requirements for supporting and securing cables within a tray can provide useful guidance. The cable should be securely fastened to the trench walls or racking system to prevent movement and to maintain proper spacing. The support should be made of materials that are compatible with the cable insulation and that will not corrode over time. It's also important to consider the ampacity of the service lateral conductors. The conductors must be sized to carry the calculated load in accordance with National Electrical Code 310.15 and other applicable sections. The ampacity of the conductors may be affected by the installation conditions, such as the ambient temperature and the presence of other conductors in the same trench. If the conductors are installed in a way that reduces their ampacity, it may be necessary to use larger conductors or to provide additional cooling. Grounding is an important aspect that needs to be taken into account. The grounding system must be properly designed and installed to provide a low impedance path for fault current to return to the source. This helps to ensure that overcurrent protective devices will operate quickly and effectively in the event of a fault. The grounding electrode system should be in accordance with National Electrical Code 250.50 and other applicable sections. The grounding electrode conductor must be sized in accordance with National Electrical Code 250.66 and must be securely connected to the grounding electrode and to the service equipment. Surge protection is another area to consider. Service lateral conductors are exposed to surges caused by lightning strikes and other events. Surge protective devices should be installed to protect sensitive electronic equipment from damage. The surge protective devices should be selected and installed in accordance with National Electrical Code 285 and other applicable sections. Coordination with other trades is another element to bear in mind. The installation of the cable trench and service lateral conductors should be coordinated with other trades such as plumbers and landscapers to avoid conflicts and to ensure that the installation is done safely and properly. The location of the cable trench should be clearly marked to prevent accidental damage during excavation or other activities. Regular inspections and maintenance are critical. The cable trench and service lateral conductors should be inspected regularly to identify any signs of damage or deterioration. Any necessary repairs should be made promptly to prevent potential hazards. The covers of the cable trench should be kept securely fastened to prevent unauthorized access. Consider potential environmental factors. The cable trench may be exposed to environmental factors such as moisture, chemicals, and extreme temperatures. The conductors and other equipment installed in the trench should be suitable for these conditions. Corrosion-resistant materials should be used to prevent deterioration of the equipment. National Electrical Code Article 300.5d4 addresses the issue of concentric knockouts. Although concentric knockouts are not directly related to a cable trench, the underlying principle of ensuring a reliable electrical connection is relevant. Concentric knockouts can create a high impedance path for fault current if they are not properly bonded. This can prevent overcurrent protective devices from operating quickly and effectively in the event of a fault. For this reason, concentric knockouts should be removed or bonded with a listed bonding jumper. If you are dealing with a situation where the existing installation does not comply with the National Electrical Code, it is important to work with the owner or operator of the facility to develop a plan for bringing the installation into compliance. This may involve replacing the cable trench with a different type of wiring system, upgrading the grounding system, or installing surge protective devices. The plan should be documented in writing and should include a timeline for completing the work. If you are unable to reach an agreement with the owner or operator of the facility, you may need to consult with the authority having jurisdiction to determine the appropriate course of action. The authority having jurisdiction has the authority to enforce the National Electrical Code and to require that unsafe installations be brought into compliance. Remember that electrical work should be performed by qualified individuals. Only qualified electricians should perform electrical work. Qualified electricians have the training and experience necessary to install and maintain electrical systems safely and properly. They are also familiar with the National Electrical Code and other applicable codes and standards. Permits and inspections are often required for electrical work. It is important to obtain any necessary permits and to have the work inspected by the authority having jurisdiction. The inspection will help to ensure that the work is done in accordance with the National Electrical Code and other applicable codes and standards. Safety is always the top priority. When working on electrical systems, it is important to take all necessary safety precautions. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and using properly insulated tools. You should also de-energize the circuit before working on it and verify that it is de-energized with a voltage tester. Proper documentation is very important. Maintain accurate records of all electrical work that is performed, including the date of the work, the name of the electrician who performed the work, and a description of the work that was done. This documentation can be helpful if there are any questions or problems in the future. In summary, when evaluating the use of a cable trench for service lateral conductors, it is crucial to consider bonding requirements, compliance with recognized wiring methods, and the overall safety of the installation. Consulting with the local power company, the authority having jurisdiction, and the utility is essential to ensure that all applicable codes and standards are met. If necessary, alternative wiring methods should be considered to guarantee a safe and code-compliant electrical system. Remember to prioritize safety and to work with qualified professionals to address any electrical concerns.